Alright, so in model building, we'll start with the full model. Full model, call it car dot red dot full. So run price against all of them. Okay, and data is equal to train dot df, and then let's do a summary of car dot rate dot. Okay. So this is going to fit a model between price and all the variables, and then it's going to print a summary of that. Okay, so here it is. Okay. And here, if you look at the stars here by the side of the p-value, okay, so it gives you 3 stars, so it is really small. Okay, and 1 star, 2 stars, so here is the legend of that. So if it is 0, very close to 0, then it is close to 0, 0, 1, 2 stars, it is close to 0, 1, 1 star, close to 0, 5, it's a dot, and then nothing for really large values like 0.1. Okay, so you can see that this one is a dot, but that's not significant because this is part of 2 variables that should be taken together. And here you see the metallic color has a really high probability that it is a useless variable, so this is something that we need to get rid of. But we don't want to ad hoc this. We don't want to just look at it manually and see which one to get rid of. We want a more systematic way of developing or throwing out variables that should be there and bringing in the variables that we need to have in the model. Okay, so that's what stepwise does. Okay, and the stepwise, so we'll call this car dot red dot step. Okay, and the method for that is step. That step is part of the stats library, which is part of objects. It's part of base objects. This is not something that we have to attach. Okay, it's always there. And there are some limitations to step. That is why we're going to look at a library that specializes in stepwise. Okay, in a second, in a few minutes. So the first one here, we're not going to specify the data, so we have to give the model, the full model. Okay. We want to do stepwise with this full model. Yeah, the entire model, and now we're going to apply the stepwise method to that full model. So specify the full model, and then you give direction. Direction equal to what? So direction can be either backward or forward or both. So we have 3 options. And this is how the 3 options work. Forward, if you use forward direction, then you start with nothing, then you go through the entire set of variables and select the best, first best. Okay? So now put that in. So it will be like here. So you look at the 5, see which one is the best. the best one is x sub 2. Okay. Now put x sub 2 in, it's in. Now from the rest of it now, you select the next best. So which means from the next combination, you're now going to only look at the ones that have x2 in it. So you're going to be only looking at these four. Okay. So with x2 already in, you put x1, so you get x1 and x2. Then you put x3, so you get x2 and x3, and then x4, x2 and x4, x2 and x5. So which one is the best among these? So here if you look at those, you see that that's the best. So you will bring in x1. So now you have x1 and x2 in the model. Okay. 3, 4, and 5 are outside. Now you try to bring in the next best, 3 or 4 or 5. And they keep going like that until you get the full model. Okay. So you will get one model of each size. And as you go further in, your search becomes narrower and narrower. Okay. So you're not doing a full exhaustive search, but narrow search. This is what is called forward. Okay. Now backward is you start with the full model. Okay. And now you're going to select the variable that contributes the least to the model and throw it out. So if you look at the size 4 models, again, you look at the best model, so you get 87, 88, so that one doesn't have x4. So you throw out x4. So now you have x1, x2, x3, x5, and from that, select the one that makes the least contribution, throw that out, and keep going back. So that's your backward elimination. Okay. Then both is every time you make a change, okay, you take a step back. So you start with forward, right? To put x sub 1 in first. And then you have not x sub 1, so in this case it's x sub 2, right? So you put x sub 2 in first. Now you have 1, 3, 4, and 5 outside. So select the next best, x1. So bring it in. Now instead of going forward to the next, then you start analyzing the variables that are already in, and then see whether because of this new addition, did any other variable become insignificant with p-value less than 0.05. If that is so, throw that out. So you do a forward step and then try to see whether there is a backward thing that you have to do, because one of the existing variables in the model is no longer significant because of the new addition. So keep going like that until you get to a point where there are no more variables to add and no more variables to kick out. So you have to specify now the cutoff point for bringing a variable in and a cutoff point for throwing a variable out. But usually it is a p-value of 5%. So if the variable that is outside has a p-value less than 5%, then you bring the best among them. Okay. And then you check the variables that are already in the model and see whether there are any variables that now have a p-value greater than 5%. In which case, you throw out, if there's more than one, then you throw out the worst one. If there's only one, you throw that. So forward and backward, and that is called. That, for that, you would select both as the direction. So let's do both. Okay. And let's do a summary of that. Summary. Okay, so that have the model. Okay. Now we can, let's check what variables are in the full model and what variables are in the stepwise model. Okay. So variables in the full model, so car.red full. So now we want only the terms. So select terms, and if you look into terms, it is the third item in the list. So when you're trying to access the list, you have to put two brackets. That's the way you have to access. We talked about this earlier in the semester. When you have a list, how do you access items in the list? You need to put two brackets. So that gives us the variables that are in the full model. Okay. Now let's compare that against the variables in the stepwise model. Okay. Car Z step. Okay. Terms. So now you can compare. Let's see. Which one is? So metallic color. We already saw that metallic color had a very high p-value. So that's gone. And the rest of it on. Okay. And if you want to look at R squared, we already have, so the R squared for stepwise, okay, is 8583, and this R squared is 8568. For the full model, 8566. There it is. 8568. So it's an improvement. I just also added improved, throwing on metallic color.